Hey guys, so for today's video, we're talking about loops in Arduino. We're talking about for loops and the control statement. And control statement, so control statement are the break and the continuous keywords. It allows to modify the function of a loop. So let's get right into it. So what are loops? So loops basically allow us to repeat a set of instructions multiple times. So in this video, I will cover the for loop, when to use them, the while loop and when to use them, the continue, how to use the continue and break keyword to modify the function of a loop. Two types of loop, the for loop. So for loop is basically used when you know the amount of time you want that particular function to happen. Let's say I want a LED to blink 5 times. I use a for loop. So while loops are used when I need to repeat a set of instruction when a particular condition is true. So use case for a while, for example, be when the motion sensor detects a person in a room. So after a person is in the room, start recording video. So when nobody's in the room, stop recording. It can be a good power saving feature when you don't want your camera to keep recording all the time. When you record when there's activity in the room, but when there's a person in the room. So can use the while loop to run something like that. So for loop. So the syntax and the for loop is the for loop, the for keyword, and the initialize. We initialize a variable. The condition for which that for loop could run until that condition is false, and increment in case you want to increment a value. So that value basically is like the counter for the loop. So let's go to code to see how it actually works. So we're going to try to use the for loop to dim an LED. Remember in our previous video we used PWM to read the patterns of LED. Now we're going to slowly dim an LED using the for loop. So let's go to our simulator, walkway simulator. So first let's begin our serial monitor. Begin level to 500. So let's add an LED to a PWM pin. My favorite PWM pin is 3, but we can also use 5, 6. Let's try something different today. Let's use 6. And connect the other lead to ground. This is the cathode connected to ground. So now we can write our code. I want to set the pin as output. In mode 3. Let's create a variable to hold the pin. Since this is a pin, I'm going to use the constant keyword. So I'm not changing the pin number, so constant int. So we'll do constant int the LED equal to what pin are we using? I'm using 6. I wrote 3 here again. I'm getting used to using 3 as PWM. So can I change this here to LED? Then we try to have an output. So first let's turn off the LED. Turn off the LED first. Make sure the LED is off first. So do LED and 0. Now we can now create a for loop. For int I equal to 0. This is the initialize as I said in the slide. Then the condition, so put a column. So I as far as I is less than equals to 255, the loop should keep running as far as I is less than equal to 255. But for every iteration of the loop, you should add plus 10. So write I plus equals to 10. If you wanted it to be 2, just add plus equal to 2. For that to be 5 plus equal to 5. For that to be 1, you can do plus equals to 1, or you can do I plus plus. I plus plus basically means I plus 1. So for every iteration, then I added the value of I. What I can now do is to write analog read and analog read to set the LED pin. Sorry, analog write the LED pin, the value of I. I want to add a delay, so I add a delay of 350 milliseconds. So the one is so when I've slowly dim the LED from off to very bright, I want to turn it back off again so it starts from the beginning. Watch the LED slowly. You see it's getting brighter, and after a while it will go off. So we can do to make us see the increment value easily is to see how to print the value of I. So let's come here and do serial print line I. So we're able to see it. So you can see I is increasing 10 and it gets to 50, goes back to 0. Immediately it gets to a value greater than 255 or equal to 255. The condition falls off and it comes out of the loop. But since our follow business side, the void loop, this is a loop on its own, it starts from the beginning again. So you change this to 5, you see that you're going to be counting addition in steps of 5. So they'll basically use a for loop now to make an LED get bright slowly. Then when it gets back, turn it off, then repeat the whole thing again. So now the while loop. While loop basically, as I said earlier, when the condition is true, it makes sure that loop is running. So the only thing you need for the while loop is a condition. So the loop will run as long as specified condition is true. So how the while loop works, the condition is checked before entering the loop. So before I put it as loop, it checks the condition. If the condition is true, the loop is executed. After the code in the loop has been executed, it checks again if that condition is true. If it's still true, it runs the loop again, then checks again. So it keeps doing like that until that condition is false, and it comes out of the loop. So we can do what I'm going to do an example. I want to blink an LED only while a button is pressed. So let's go to. So I want to blink this LED only while a button is pressed. First, let's write code for blinking an LED. Now, if we run this, our LED should blink every 1 second. Now, we want this blink to only happen when a button is pressed. So let's get a button. So what comes to our mind? Let's try different. I'll read this push button before. Let's try a different switch or different kind of button. Let's use a switch now. So I'm going to use this light switch. This light will basically have a command. So when I move this switch this way, it moves this direction. So you connect. If I move it this direction, it connects this switch 1 to switch 3. If I move it in this direction, which is currently at the position is currently at, when this and this are connected. So I'm going to connect this pin here to ground. And this other pin, let's connect it to pin 12. Let's give it a different color. Blue. Black. Let's give this one a color. So let's make a switch pin mode 12, comma input underscore pull up. Or we can also create a variable for the button also. So constant. So I'm using constant integer for pins because the pin number, normally we don't change the pin number during our code, so I put at a constant, so it doesn't change. So if I mistakenly try to change the pin number, it will raise an error. So this is a better way to store your pin numbers in variables. Switch equals 12. It's easier to just write 12 than to type switch. Oh, switch is a keyword. Let's use capital letter S, switch. Let's put everything in uppercase. Switch. Switch. So the color change was blue, but switch is a keyword. Later in this course, I'll teach you about the switch. So normal set as input below. Now we can now come here. So by input below means that by default, the default position of the button is going to be high or true or 1. So anytime I flip the switch to this direction over here, it's going to connect this pin to ground. So we're going to be receiving 0, which is same thing as false. So in the while loop, I'm going to check now in the while loop. The condition in the while loop now will be if the button is equals to false or is equals to 0, if the state of the button is equals to 0, then the blink function, this code wrote for blinking here should run. So we're going to do digital read. While digital read switch. So data switch equals. So we use the two equal to for when we're comparing values. That means 1 equal to when we're assigning values. So check if it's equal to 0. So if this condition is true, if it's actually equal to 0, then I'm going to encapsulate this whole code here, inside the loop. And this layer will only blink if this switch is in this direction here. So if we run our code, hope there are no errors there. To run our code, the LED will not blink unless I flip the switch. Let's see. So remember that's about while allow us to run like a block of code only when a particular condition is true. So while loops are actually ideal when we don't know the number of iterations, and we don't know how many times we want it to happen. But if you know how many times you want a particular thing to happen, we can use for loops. So let's go back to our code, to our slide, sorry. So going to the break keyword. Just try to write the break, but you just have to write break. So break basically allows you to, as I said, break out of a loop. So let's go back to code so I can show you how it works. Let's remove this. Okay, now this is what we wrote earlier when we were doing for loop. So we want to add a new feature to our LED now. The new feature is that, remember we're trying to raise the brightness of LED from 0 to it gets a maximum value. So we're gradually making the light brighter. So when it gets to maximum brightness, it goes off, then repeat the cycle again. What if I'm trying to save energy? I don't want the LED to get its maximum brightness. I want it to break out the loop at a particular point. You want to break out of the loop when the brightness is at 150. So how can I do that? So I use the break keyword. Well, I call it the break statement, but I think it's better I call it the break keyword. So let's do that. You should know the correct way to call it. You can put it in the comment section. Someone was telling me it was break statement to call it, but I think it's better called break keyword. But let's go on. So now for you to the break keyword, I can type here like if. Now I don't want the LED to get to maximum value. I want to stop at a particular value, but I'm trying to save energy. So I can do if I is greater than or equal to 150. So it's not. So when you make it value of I become greater or is equal to 150. This if statement will run. So I'm going to put the break keyword inside there. So immediately if I is greater than or equal to 150, it breaks out of the loop. And notice that it's going to go back to 0. Originally it was going to get to 55. But now with this, what I'm writing here, immediately it hits a value greater than or equal to 150. It come out of the loop. But since our for loop is also inside the void loop, we're going to go back to 0 and continue. Let's do that. Let's change this back to 10. 5, the steps of 5 is too small. So if I run this now, if you look at the serial monitor, 30, 40, 50, 60, 70, 90, 100, 120, 130, 140 goes back to 0. See, never gets above 150. So that one you can use the break. If in case you want to break out of a for loop or a while loop, you can use the break keyword. So next is the continue keyword. Basically, continue is a control statement that allows you to skip the current iteration of a loop based on a certain condition. So you can like skip one iteration. So if I'm counting 1, 2, 3, 4, 5, if I put continue, you skip 6, then go to 7. So let's go to our slide and look at it. You can just basically write it as continue, just like break. So I'm going to use this in an example. I'm going to use it to print. First, I'm going to try to print just all the numbers from 1 to 100. You can add the continue statement, the continue, okay, whatever, continue keyword or continue statement. We can use, I want to use the continue keyword to skip all even numbers. So you can get only odd numbers, or skip all odd numbers so you can get only even numbers. So let's do that now. So you go to our code. Let's clear this off. Okay, let's not clear everything. I don't need this anymore. I don't need this. And just ignore the switch executor. So let's clear all this. So you can see this loop. So we're going to use I++. So I++ is the same thing as saying I plus equals to 1. Let's add 1 to it. So I want to print all the numbers from 1 to 100. Let's put this in the setup so it happens only once. So we don't even need the LED anymore. So you can do serial print line. Just to press this print line. This basically print. Let's start from 1. Basically print all the numbers from 1 to 100. Let's run the code. So print all the numbers from 1 all the way to 100. So we can now use the continue keyword to now skip some values. So I want to print only, let's try to print only even numbers. So I'm going to skip odd numbers. So you can now do now. So what is the property that, or what odd number, what separates odd number even numbers is that when you divide one of them by 2, you get 0. Because when you divide even numbers, the remainder is 0. When you divide odd numbers, you get remainder as 1. So you can write an if statement that if remainder is 1, skip it. So you're going to skip odd numbers. So if you get a reminder, use the modulo sign. So you can do if I, so the modulo sign is basically the percent sign. If I modulus 2 equals 1. If equals 1 is basically an odd number. Those are the comments. It is an odd number. So you cannot press continue. Well, that okay, but now we have to put it. And if I were to run this now, we'll still get the same exact thing that we got here, but code runs line by line. So I wanted to skip before it prints. So I have to put it above the serial.print. So I'll cut this off here and put this here. So when we refresh this, you can see now it has skipped all the odd numbers, say 2, 4, 6, 8, 10, 12. The same thing here, I'll change this to 0. This is a comment, doesn't affect our code, just for writing text. If I change this now, we'll get all odd numbers, so you can see. So the continue keyword basically allows us to skip part of our loop iterations. So it's time for us to conclude. Conclusion. I'll just try to recap our conclusion. So for loops, so basically use for loops when we know the amount of iterations, the amount of times we want the loop to run. We use while loop when we want a particular function to be carried out when a particular condition is true. Remember the camera analogy I gave you, where you want maybe your CCTV camera out to only record when there's a person in the room. So immediately that condition is true that the person in the room starts recording. So when to use, which I basically said that use for loop where you know the number of iterations. You know the number of iterations. So the break keyword allows us to basically break out of the loop. Imagine a circle. When I said the break keyword, it breaks the circle, so it's no longer a loop again. It breaks us from the loop. Continue keyword basically allows us to skip an iteration. If I was going 1, 2, 3, 4, 5, and let's continue, I'm going to go back, skip 6, then I'm going to go to 7. So that's all. So thank you guys for watching. I hope you liked this video. If you love the video, please subscribe. Please subscribe if you love this video and leave a like. And if you have any question, drop it in the comment section. Drop it in the comment section, and I will try my best to reply you. Thank you, and I'll see you in our next video. Bye.